Okay, welcome back to Robots Remake the Workplace. We've got a special treat for you to kick off the second part of the program. Chris Anderson is here from San Diego to talk about his second career, might be his third or fourth career for all I know, but he's going to tell you about the drone revolution at 3D Robotics. As soon as he's done talking to Vivek over there. You're on, Chris. Chris Anderson, 3D Robotics.
Thank you. Sorry, I was caught in conversation. Well, first of all, thank you for doing this. Thank you, everybody, for coming. I'm really excited about the fact that people are recognizing that business is now possible with robotics. It wasn't for a while, with the exceptions like Rod and a few others out there. Robotics was too hard to build businesses around. And I'm going to just tell my story here about, today I run a multi-million-dollar robotics business. And 5 years ago, I was playing with Lego with my children. And I just want to, we make these things here. These are drones. This is a hexacopter called an arducopter. This is it's like an agricultural crop mapping plane. 35 minutes ago, this was leading a swarm of other hexacopters in the Berkeley Marina. I just raced down here. And 5 years ago, I was playing with Lego with my children. I just want to tell you sort of the story of how we built a business around this and why regular people can do it and why now. And then maybe we'll have some time for questions if possible. So what happens is that 5 years ago, I'm playing with my kids with Lego Mindstorms, and they're bored out of their skull because it's really hard to impress children, especially about robotics, because CG makes it look amazing and easy, and in fact, robotics is hard. And I was just trying to think of something that would interest the kids with robotics, and I thought, what if the Lego could fly a plane? And so we built a Lego autopilot with the sensors that come with Lego Mindstorms, gyros and accelerometers, magnetometers, Bluetooth, compass, ARM processor, etc. And it kind of almost worked. And it flew and almost navigated. And it turned out that was not sufficient to interest my children, and they lost interest immediately. But I went down the rabbit hole, and I started this community, DIY Drones, 5 years ago. And the point of this community was to what I call being ignorant in public. I knew nothing about the subject. I thought it was kind of amazing that I got a plane to fly with Lego and autonomously. And I literally had to Google drone. And eventually I came up with this thing called a Kalman filter, and it seemed super complicated, and so I just kind of didn't bother. And today that Lego unmanned aerial vehicle is in the Lego Museum in Billund. And I built that with my kids around the dining room table, about 10 minutes after Googling drone. And I thought, gosh, that's one, we're here in Silicon Valley. I don't get sort of, chills often about technology. But when you can build an autopilot on the kitchen table with your children out of Lego, you know something's changed. And I wasn't sure what it was exactly that had changed, so I created this community to be stupid in public. And so I asked dumb questions, and people started answering them, and I kind of liberated other people to ask dumb questions. And together we built, I think it's the largest robotics community in the world. I don't know whether there's a larger robotics community than this one. What this community did is it started pulling together people who had an interest or an expertise or something to add. And robotics, as you know, is like the most interdisciplinary technology field there is. And it turns out that you need analog electronics and digital electronics and aerospace, and mechanical and design and software and the control algorithms and radio algorithms and optical and image processing and so many different fields. It turned out everybody had something to add. And together we started building drones. Or more to the point, we started building designs for drones. And then people were like, this is fantastic. We have an open source software and hardware and the Eagle files for the CAD and, and the documentation and the ground stations. And at this point, if you were sufficiently competent, you could download the files and have your printed circuit boards fabbed and then order the components from DigiKey and then hand solder them. And needless to say, this was way too hard. So they said, can we just buy this, please? Can you just make it for us? And so that's what we did. I decided to start a company. Again, I knew a little bit more because I was I'd had the site and it was going pretty well. But one guy on the site, this guy Jordi Munoz, was clearly the smartest guy in the world. He had, at least in our space, he was flying a helicopter with a Wii controller. And he was using an Arduino as the control board. And like, you know, this was 2007, and I'd like never heard of Arduino. I didn't realize you could hack into Wii controllers. Didn't know that regular people could fly, you know, helicopters with this stuff. And he posted the code and videos and documented it. And you know, he was our tutor. And he seemed like the right guy to start a company with. So I said, let's start a company. He said, all right. And I said, we'll start with these boards, and then we'll make this blimp. And he said, fine, let's do it. And I said, you know, actually, tell me a little bit about yourself. I never met him. And it turns out that he was a 19-year-old, just graduated from high school, living in Tijuana, Mexico. And today he's the president of a multi-million-dollar robotics company. He still has not graduated from high school. He only lives half the time in Tijuana, Mexico. And our whole team is mostly now 24-year-old Mexicans from Tijuana. And, you know, if you'd asked me what the odds are that the editor-in-chief of Wired magazine would quit his job to start a robotics company with a teenage high school graduate from Tijuana, the odds would have been low. But if you'd asked me if I was going to start a community and start a company with the smartest guy in the world who had self-identified in this community and understood open source hardware and open source software and what was changing in the world of technology, I would say, of course. It just so happened they were one and the same. So, the reason that I can do this, and by the way, this is the kind of stuff we make. This is an autopilot. This is a little black box. You put it in any vehicle and it becomes a drone. It's got 14 sensors and GPS and, you know, lots of software and 3 processors, et cetera. It costs $179 with all that stuff. And it's a universal autopilot. It's the world's first universal autopilot. You can put it in any vehicle, copter, plane, multi-copter, car, boat. We haven't tried submarines yet. I had a little problem with GPS underwater, but you put it in anything and download, you know, press a button and it downloads some code from the internet and turns it into a helicopter autopilot or a airplane autopilot or a multi-copter autopilot or rover autopilot. And the reason we can do this is because, as you guys know, and we probably discussed earlier today, there's an extraordinary thing going on in your pocket, if that doesn't sound wrong. That the smartphone revolution has led to an acceleration of Moore's law like we've never seen before in the components that are in a smartphone. The MEMS sensors, the GPS, the camera, the ARM core processors, the memory, the wireless, the battery, and all that. And thanks to the economies of scale of Google and Apple and others, these components are now available to everybody. And the same way that the 8088 started the personal computer revolution, suddenly a chip became available at a reasonable price. Now, these sensors and processors and wireless and cameras and GPS, et cetera, are available to all of us at a reasonable price. And this is the Cambrian explosion of robotics. Robotics are the peace dividend of the smartphone wars. And the reason we can do this is because we use the same parts. This is just smartphone parts reconfigured with different software. And these sensors, we use 9 degree of freedom sensors, all these combined, and they cost like $7. And the GPS modules cost like $8. And it's just, we kind of, if we have a hard problem, we just wait 6 months, and Apple makes it easy. This is a great thing. We draft behind the smartphones. We just go where consumer electronics is already taking us. And we don't do anything hard ourselves. We just use the available technology that is getting faster and better at a rate that we've never seen before, at least not in my career. So this is again what an autopilot looks like. This is just with a power module, et cetera. Now we've switched to, we started with Arduino because it was an open source platform, and it wasn't the best technology, it was the best community, and we always put community ahead of technology. It had the libraries, it had the code, it had the documentation. It was just easy to use, and that's much more important than the CPU speed or bits and all that stuff. We then switched to ARM, which subsequently matured, and so we now use a 32-bit ARM Cortex-M4 processor, which again comes out of the smartphone industry. And we now work with a Swiss university called ETH in Zurich on this. And this is what happens. This is a multi-copter drone. That's a hexacopter. This is a plane. And what you do is you just sort of you just plug this little board into a vehicle, any vehicle, and then just decide what vehicle would you like to be. Would you like to be a rover or a car or a rover or a plane or a helicopter or one of these various multi-copters? And poof, there you have it. And that's kind of A, that's never been done before, and B, it was done by a bunch of amateurs working online on the internet for free. So there you go. This is what this is what the difference between drones and radio control vehicles. Drones are capable of autonomous flight, automatic takeoff, landing, they follow a mission. This is a mission planner. You just click on the map, and there's a waypoints, and each waypoint has commands, loiter, change altitudes, follow an object, look at a region of interest, turn on cameras, things like that. And this is a very different approach. You don't need to be a pilot. The autopilot does the flying. Humans should not be operating heavy machinery, drunk or not. Computers are really good at that. What we should be doing is like, what's the job here? What are we trying to do? Are we trying to survey an area? Are we trying to follow an object? Are we trying to put a camera in a certain place? Do you want this to be a long camera boom, and you just want to script the direction of the camera? Here's the set. It's Hollywood. It's the actors are here. Swing around, go to 400 feet away, then kind of zoom in till about 30 feet away, and hold the camera there, then yaw around, etc. This is the kind of artistic control you want to give a camera. This is the way a camera, a director thinks of what the camera should do. They don't care how the camera gets there, nor should they. The drone figures it out. They just think about what the end result will be, and that's the difference between drones and the previous generation of teleoperated machinery goes, is that you think about the mission. You think about the highest level of what you're trying this thing to do, and you let the software and the hardware figure it out. What happens when you build this kind of advanced technology through a community, and it's open source, and it's free, is that you bring the prices down dramatically. These things cost about $500. These are military-grade drones, more advanced, actually, than most military drones. Not because the military can do it, but because they're focused on reliability, and we're focused on sort of features. So the level of autonomy that ours are capable of is much more than, for example, a Desert Hawk or one of those small handheld military ones. And ours costs like 1/1000th the price. And when things cost 1/1000th the price or further, then you can start adding words like personal and classroom and disposable. I love the word disposable. Disposable is not something that Boeing is going to bring you. Right? Boeing's not oriented around the cost dimension. They're oriented around the reliability dimension, and those are all good. But the military industrial complex, the aerospace industries, don't explore cost. They're built around cost plus accounting, which is the way military procurement works. And so who's going to explore that cost dimension? And the answer is regular people who are price sensitive. And so when you have disposable drones, when you have drones that cost, ours cost a few $100s now, but soon they'll cost a few tens of dollars. So when you have a $90 drone, you can send 100 out, and they don't have to come back. You just cover a lot of land. By the way, if they don't have to come back, it doubles their range. You just go further. We have drones made out. That right now is made out of EPP, a special kind of foam. We have other drones made out of starch-based foam, and they used for Arctic and Antarctic mapping. And they double the range, and when their battery runs out, they just drop into the ocean and they melt. It's the starch-based foam melts in the water, and that's fantastic. When things aren't expensive and aren't secret and aren't big and heavy and dangerous, and they don't have to come back, then you can waste drones to get the job done. And that's exactly what we did in Silicon Valley with transistors and bandwidth. And now we can waste robotics by making it super, super cheap. And that's something that the bottoms-up model allows. This is the way I started. I said I start with Lego, and they said you should make stuff and sell it. And we said, okay, we'll make a blimp. And so here is the first blimp assembly line. I don't think we had a company at this point. It certainly doesn't look that way. The labor is my children. We pay them with strawberries and juice. Lesson, do not put the 6-year-old on quality control. She won't do a good job, and the customers are not sympathetic when the parts are missing from the kit. We made lots and lots of blimp kits. Lesson 2, when you're starting your own business, don't dare be successful, because it turns out you've got to make more. So we hit the scaling limits of our dining room table assembly line pretty quickly. This is Jordy, my co-founder. This is how he started. He was hand assembly stuff, and this is pretty much where I thought it was going to stop. I was like, Jordy, the girls don't want to build many more blimp kits. Can you do this, please? And we thought we'd sell a few hundred, maybe a few thousand. Something Jordy could hand assemble. And this is kind of the way. This was the end of it. I had a day job. I was the editor of Wired. And I just assumed the community would be sort of making this little sort of, toy stuff on their own, pretty much like that. And then he sent me another picture. And then he sent me this picture. He says, "Hey, Chris, I got a space." And I was like, oh, cool. And it wasn't the space that sort of impressed me in the ducks. It was the fact that we actually had shells. I was like, wow. And then he says, oh, and we have a bookkeeper. There's Rebecca. She's a bookkeeper. And I was like, we have a bookkeeper. This guy, this 19-year-old guy, he seems to be pretty good. And then he sent me another picture. And he was like, we have pick-and-place lines. We have CNCs. We have reflow ovens. We have stencil printers. We have employees. We have uniforms. We have ESD protection. We have an ERP system. We're going for ISO 9001 compliance. And then I thought, it's time to quit my job. And so on the basis of this, I realized I had chosen the right partner. By the way, what 19-year-olds, here's three things that 19-year-olds know. Well, actually, one that they know and two that they don't know. One is they know a lot about technology, that it's kind of animal instincts for things like open source and Arduino and all that kind of stuff. They're really, really good at that. Number two, they don't know that you're supposed to have degrees and credentials to do this stuff. They just have the internet and they just learn stuff and they do it. And number three, they don't know that you're not supposed to build factories. You're supposed to pay factories to make stuff. You're supposed to give your stuff to factories and let the factories make stuff. You're not supposed to build your own factories. Factories are supposed to be hard. And the first pick-and-place machine, this is this thing right here, the first one he bought on eBay. It was used, and he downloaded the manual from Google. And he just figured it out. And the whole team is like, they're all 24, 25-year-olds from Tijuana who just did it. And another thing that kids from Tijuana know is that if you want to get stuff done, if you want to compete with China, if you want to make electronics at world-class levels, but at price parity with China, Tijuana is where you're going to do it. All the screens, all the flat screens in your world are made in Mexico. That's where Samsung and Foxconn are. If you want to hire someone who's been working for a multinational electronics assembly company for 10 years at ISO 9001 levels, you can do it in China and you can do it in Tijuana. You can't do it here, or at least not affordably. And I suddenly discovered that Tijuana, which I thought was drug cartels and cheap tequila, was in fact the Shenzhen of North America. And San Diego is the Hong Kong, and bang, we now have we're now competing with the Chinese, who are awesome competitors, but we've reached price parity with the Guangdong. This is our Tijuana operation. That's the clean room where the pick and place works. Again, they send me these pictures. I now go down there pretty often, but originally they send these pictures. They not only have uniforms with our logos, but they have electrostatic discharge booties. And I was like, oh, that is awesome. We have booties. And they blow ionized air over the work surfaces to avoid electrostatic discharge, et cetera. And these people, they were all working for Samsung or Foxconn, a while ago, and now they're working for us. And we know nothing about manufacturing, but we don't have to because they know stuff. And we hire people and we're like, how did you do your job for Samsung? And they're like, well, here's the documentation and here's the process and here are the titles. And we're like, yeah, could you just do that here too? And it's amazing. Who knew, right? So these are our new facilities. This is our Tijuana facility we're just moving into. This is our new San Diego facility. Remember, this is 3.5 years after I was assembling blimp kits of Lego with my children on the dining room table, fueled by strawberries. And now this is what we're doing. And in December, I quit my job at Wired to run this. And actually, this is my 100th day, or not, yesterday was my 100th day. And we were venture-backed, and we had True and O'Reilly Alphatech did a $5 million round in December. And we're about 70-ish people, I guess. Probably going to be 100 plus by August. We will be bigger than Wired in terms of employees within 4 months of joining, and it's just an amazing time to be starting a company in this space. We cannot keep up with demand. So I just want to say, so that was what we're doing. That's the company we built, and just the lesson here is things that used to be hard are suddenly easy. It's easy to build technology. It's easy to get, these chips have made it easy. The open source hardware, the open source software has made it easy. It's easy to start a company. It's easy to start a factory. It's easy to go on Google and learn about ERP systems. It's easy to hire people who know these skills if you go to the right place. This stuff, we're building an aerospace company, and we're a bunch of amateurs who just got together and decided to do it. It's an extraordinary time. So what are we doing? What is the point of these drones? Why does anyone need a drone? Well, I'll start with some trivial examples, then I'll go beyond trivial. So how many people here have flown a model airplane? Good. How many people here has crashed a model airplane? What a surprise. Exactly. Flying is hard. How would you like to not crash? Well, along with doing sort of, missions and GPS waypoints. Another thing an autopilot can do is stop you from crashing. This is called geofencing. What you do is you just define a border. You said, don't leave this border, and this border has a top and a bottom, a ceiling and a floor. And this is a data log of us trying to break the geofence. What happens is this works mostly with planes, but you give the controller to a kid, and the plane's in the air, the kid's never flown before, and you say, hey, fly. And the kid, let's say the kid does the worst possible thing. They just jam the elevator stick all the way forward. It hits, at 100 meters, it hits the floor of the geofence, takes control away from the kid, brings it right back to the loiter spot in the middle, and then loiters until the kid takes control back over again. And that's an awesome thing, right? I mean, of course, these things should be smart enough not to crash. It's like riding a horse. Do it for fun, not because you need to get from point A to point B. Fly for fun, not because you need to keep a thing in the air. We have moved, another problem with radio control airplanes, as many of you know, is that these controllers are incredibly arcane. They have all these buttons and hard to set up, et cetera. So we think that those are kind of the wrong way to go. So now we've moved entirely, well, not moved entirely, but now we support mobile platforms. So we prefer the Nexus 7 Android, but we also support any mobile platform. We have an HTML5 ground station that renders in the browser. There are apps you can download. Android Pilot's a fantastic one for Android. It's free. There's one on iOS. There's a Kickstarter Indiegogo project right now from guys called Fighting Walrus who have an actual device, that you plug into your iPhone or iPad. But you shouldn't fly. You should just tap. You say, go here, and then you stretch out. Look at that, loiter, etc. That's how you. That's what drone control is actually like. We think it's fun to do things like put GoPro cameras in the air. GoPros are awesome cameras, but they're even more awesome when they're 30 feet up and 30 feet back and looking at you from the air. How do you do that? And the answer is the follow me function. So if you have a Nexus 7, you can do it right now. Just put the thing in your pocket, or most Android phones will do this as well. Put the thing in your pocket, run the Android Pilot code, and what happens is that when you say, follow me, and you're windsurfing, as one does, the thing takes off from the beach, comes out, positions itself 30 feet back, 30 feet up, with the camera focused on you, and then just follows you around as you do your thing. And when the battery gets low, it flies back to the beach. This is, again, Boeing's not going to bring this to you. This is what a bunch of amateurs will do if allowed to, which they are. This is a movie, Looper. Anybody seen Looper? Okay, this is a scene, just a scene you may not even notice. She's just left this piece of farm equipment, and oops, what does that farm equipment do? Why, it flies over the field, and it looks like a drone sprayer. Just a throwaway scene from Looper. It's science fiction. I go to Davis, 40 minutes up from Berkeley, and they're doing it right now. We have a team working on the fields of Davis. Agricultural drones are the biggest business there is. It has the highest economic potential and the lowest regulatory barriers. Let me explain this briefly, because this is, when you talk about commercial use of drones, when everyone says drones, they think, oh my God, weapons, military, Hellfire missiles, privacy invasion. Nobody thinks farm equipment. And yet, the most likely experience that most of us are going to have with drones over the next few years is going to be going up and down, driving through the farmlands of California and seeing drones doing crop survey, or even crop spraying in this case. Here's why. I'm slightly exaggerating here, but farming is an information problem. We basically are getting bigger and bigger farms with fewer and fewer people. And we use monoculture, set seeds to try to sort of treat the whole farm as one single plant, but it's not. Soil's different, disease is different, et cetera. We don't know. We don't know what's going on the farm because it's too big, tens of miles big, and they have no way to get that information. So the worst thing that can happen to a farm is disease. Pests, fungus, weeds, things like that. And so we prophylactically spray chemicals on our crops. We spray pesticides, fungicides, and herbicides on our crops because missing a disease outbreak is super expensive. It'll kill your crop. Why do we do this? Why don't we just wait for the disease outbreak? And the answer is the disease outbreak probably is happening somewhere out there in the fields. And by the time you find it, it's too late to spread. What if you had a morning crop survey that could just say, here's centimeter resolution, picture of your crop this morning, and all clear. You wouldn't spray the chemicals. Or what if they said, here's that same crops area, and look, there's a little dark patch over there. You would go to that dark patch, and you would check it out. And if it was, in fact, a problem, you would treat the problem. rather than spraying herbicide, sprayed fungicide because it's June. That's what we do right now. We spray fungicide. We spray an entire crop with fungicide in June because it's June. That's when you do it. We don't spray it because we have a disease. We spray it to ensure we don't have a disease. But if we could tell that there was no disease, we wouldn't spray. Or if we could tell that we did have a disease, we would just spray there. And we are spraying way too many chemicals on our fields because we don't have enough information. We are overspraying because we're underinformed. And this little ridiculous piece of foam right here, this right here is designed to be an agricultural drone. This one was also flying today and mapping the Berkeley Marine at centimeter resolution. Actually, its big brother was. This one was not. But you just toss this out the window. Farmer wakes up, 7 o'clock in the morning, maybe just presses a button, presses a foot pedal and launches. Does it auto takeoff, does its lawnmower pattern, takes a photo, predetermined period, stitches them together, gives it to you, maybe with video, maybe with not, certainly high resolution, maybe multispectral, maybe not, maybe do it at night so you can see the moths that only come out at night and under thermal. And now, after breakfast is done, you've got your daily crop report. Google, bless them, is not going to, their satellites don't come by every day. They're not always under the clouds. The data is not high enough resolution. We know we have an information problem out there. This is why we have Google's cars traveling the roads. But the air is another information problem. We don't have Google's drones in the air. And maybe Google's not the right one to do it. Maybe farmers can do it themselves. But that's the economic potential. We can use less chemicals, improve productivity, and stop poisoning the ground, to say nothing of our food. That was the economic benefit side. The regulatory side is this is the perfect place to deploy drones in the commercial market. It's private land. It's under 400 feet. It's visual line of sight. There's no built-up areas. It's flat. There's no obstructions. There's no people. It's often done by the owner themselves. It's the perfect place to do this with very little risk. Taco copter is the wrong way to do it, right? You don't want flying lawnmowers landing on children's heads to deliver, food or anything else for that matter. What you do want is farmers using farm equipment on their own land in a safe context for huge economic and environmental benefit. So this is AUVSI, the Industry Association. This is their estimate of the size of the agriculture market. It dwarfs everything else. And this is why we have teams around the country, but especially in Davis and Kansas, doing it right now. And we think this is going to be big. We think there's some really interesting opportunities with payloads and imaging. We're just doing optical right now. We think thermal, really low-cost thermal, could be super interesting. A lot of disease can only be seen at night because the leaves demonstrate their disease when they radiate heat. And we also think it's the place where the sort of the political and social and PR and regulatory issues that come to mind when people think drones, these go away when you just think farmers using it for their own purposes. So these are just one, right now we started here with hackers and hobbyists and DIY, et cetera. We're moving here to many of you heard of like the Parrot AR drone and others. It's not actually a drone because it's not autonomous, but it's got a great user experience. You open the box, it just works. You control it with an iPhone or Android. Actually, they got sued, and so they can't control it with an iPhone anymore. But you can control it with Android. And it's a great experience. What if you could have that experience with a real drone? So that's what we're coming out with later this summer. And then once we originally the reason we were coming out with this super easy to fly, super reliable, just open the box and it works, real drone, is that one of my venture capitalists has a 9-year-old son named Max. And he said, love what you're doing. I want to get one for my son. Can I buy a drone for Max? And we said, no. We don't want Max flying that. It's too dangerous. It's too hard to set up. Requires too much skill. We're not comfortable with Max flying that. And then we realized we should have a copter that Max could fly. So we called it the Max Copter. That's our code name. We'll give it another name when it comes out. But what's great about developing for Max, developing for 9-year-olds, is if you get it right for 9-year-olds, it's right for farmers. But the inverse is not true. And so that's what happens. We started here at the DIY science experiment bit that developed the technology, built the platform. We then evolved the platform so it's easy to use, exactly like the personal computer. The Apple II, the Apple I was like this plywood box. Apple II was better than the Mac. So we've done the Apple I, we've done the Apple II, now it's time for us to do the Mac. And once we do the math, then we can see what happens when regular people use these things for their own purposes. You know, we saw what happened when the personal computer got in the hands of regular people. They figured out what it was for, video games and email and word processing and spreadsheets. We saw what happened with the internet. Once we got the protocols done, the TCP, IP, and the HTML, et cetera, then regular people figured out what the web was for, and they filled it with their own ideas and passions and energies and contexts. And now we have the opportunity to do the same thing with robotics and drones in particular. We can make it easy to use and cheap and ubiquitous so that regular people can change the narrative, can take it away from military, weapon, privacy invading, and turn it into the kind of thing that we know so well from personal technologies, which is to say, it's a tool to let us do our jobs better. And these are all these verticals that we're going to be exploring from there. We basically have a platform. Our platform allows anybody to, it's because it's open, allows anybody to add to it whatever's right. So the tomato farmer wants one thing, the wheat farmer wants another, the vineyard wants a third, fruit, nuts, etc. Likewise for Hollywood, likewise for search and rescue. I could go on for hours about this. The point is, I don't know anything about any of those fields, and I shouldn't have to. And they don't know anything about technology, and they shouldn't have to. We have an open platform, and they can customize that platform and add those features that are right for that vertical. And that's how we build a market. That's how we build an ecosystem, and that's how we build a platform for innovation that's going to, if we play our cards right, and we and others like us are going to disrupt the aerospace industry. Thank you very much.
Thank you, Chris. I don't think we have time for Q&A, unfortunately.